Okay, today we're looking at lesson 4, using trig ratios to find angle measures. So the goal is to determine the size of an unknown angle in a right triangle using sine, cosine, or tangent ratios. In the previous lesson, lesson 3, we go back to it, we use the trig ratios to find the side lengths. And we use either the sine, cosine, or tangent ratios to find the missing side length. But in this case, we had to know two of the sides. If you go back to the examples we did yesterday, we were given the opposite side and the adjacent side. And we did a few examples with those. An example would be here. We were given an angle and a side, and we need to find the opposite side. So we were finding sides yesterday. Today, we'll be focusing on finding angles. And also, we can also find the side lengths. But mainly today, we were looking at when we're given the measurement of two sides, find the angle. As compared to yesterday, we were given the measurement of the angle and one side to find the measurement of the side length. So we'll step up. Just to review your trig ratios, sine is opposite over adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we'll go through 4 examples today, and then you'll be assigned assignment 4 in your booklet. So trig ratios can be used to find the missing angle in the right triangle. The trig ratios is chosen and set up in the same manner, but the calculated function is different. And I will help you through the first example. So you need a trusted calculator. No question about that. There's no answer for that. You need your calculator, and I'll clear mine. And you have to make sure you're always in degree mode. So maybe your calculator, you may find that is in D, as in the letter D, or delta. So first step, we want to know, have our trig ratios beside us, just to remind us if you're on the right track. So give myself some space here. Let's go up. So first step is to look at what's given and label the sides of a triangle. So this is my angle here. So I'll label my sides. So the side opposite the angle is the opposite. And this is the hypotenuse because it's opposite to 90 degrees. Now I write down what's given. So what's given, you're given the opposite side, which is 26 meters, and the hypotenuse, which is 41 meters. And I'm asked to find theta. Now, there are 3 trig ratios, the sine, cosine, and tangent. And I have to decide which given. I'm given opposite and hypotenuse. And then I find them where these are matching. So opposite and hypotenuse is sine. So I'll use my sine trig ratio. So sine theta is opposite over hypotenuse. Then I substitute what's given into my trig ratios. So step 1, down. Step 2 here, we substitute given values into trig ratio. Sine theta is 26 and the hypotenuse is 41. Now, this is where your calculator will be used differently as what you were doing before. In the previous incident, in the lesson, we go directly into a sine function. So it's a little bit different process in this case. I'll show you on the calculator. Now I need to find the angle. So I'm looking at. So in this case, what I'll have to do is to press my second button, my calculator, because it's inverse of the angle. So I'll move this over. Let's see here. So to find the measure of theta, which is my angle, I'll have to press my second button first. So that's it's in blue in this graphing calculator. Now in your calculator, you may find it be a second button, or you may find it a inverse button. Next, I will press my sine function. And now I enter my values, 26 divided by 41. And in my case, I'll press the enter button, just right on here. In your case, it may be the equal button. Press my enter, and that gives me a value of 39.35. So I'll run that to 2 decimal places. So theta, which is going to be 39.36 degrees. So theta is 39.36 degrees. So be careful whenever you're finding angle, the measurement of the angle, you have to press your second button first, then your sine. In this case, I'm pressing the sine button. I'll show you other cases where we have to use the cos button or the tangent button. It follows the same process, but you'll have to use the different trig ratio. So now I could safely indicate here that theta is 39.36 degrees. And I can highlight that with a yellow highlighter. Go into the second example. In the second example, we have a slightly different shape, orientation, I should say, different orientation, but that shouldn't confuse you because we'll use the symbol given here is angle. So the side opposite the angle is the opposite side, and the side adjacent to it is the adjacent side. So step one, I'll be labeling my triangle. That's step one. Then I will write down what's given. So given, I'm given the opposite side, which is 42.5 kilometers, and the adjacent side, which is 19.7 kilometers. And I'm asked to find theta, which I don't know. So here again, I go back to my trusted trig ratios, and I try to find a match where there's opposite and adjacent. So here I have opposite and hypotenuse for sine. Now that won't work. I have adjacent and hypotenuse. No, cosine cannot match. But now I have opposite and adjacent. So that's tangent will match. So I'll write that down. So step one, I'm going to write down my tan theta opposite over adjacent. So now I substitute given values into trig ratio. So we have 10 theta, opposite is 42.5 kilometers. And my adjacent is 19.7 kilometers. And this is where I go back to my calculator. And in this case, I still have to go back to my second. Press my second button first. Then I'll press, in this case, 10. That's my 10s. Press 10. Then 42.5 divided by 19.7. Close bracket and enter. And that'll give me 65.13 degrees. So theta is 65.13 degrees. So I can indicate that in my triangle here, which is 65.13 degrees. I'll put a beautiful highlighter there. Okay, so these steps here are very critical to determine the angle measurement. Let's look at a third example. Step 1, we label our sides. So label, this is my theta, so this would be the adjacent side. And this will be the hypotenuse. So we have adjacent and hypotenuse. So we're given the adjacent side and the hypotenuse. So it's given adjacent 13 feet, hypotenuse 21 feet, and we're asked to find theta, which we don't know. Question mark. So I'll go back to my trig ratios. Where do I see where we find adjacent and hypotenuse? Adjacent and hypotenuse would be cosine. So now we'll use our cosine ratio, because opposite hypotenuse would match because we have our adjacent side and we have the hypotenuse. So we use our cosine. So cosine theta is adjacent side divided by your hypotenuse. Then we substitute adjacent, which is 13, to my adjacent, which is 13. Hypotenuse is 21. And now take my calculator with second cos. So put a calculator here. Won't work. Clear my calculator. So a second button cos 13 so I'll do this again. Second cos 13 divided by 21, close bracket. In my case, I'll enter. But you, at this point, will press your equal button. In my case, I'll press the enter button, which is right here. So that gives me 51.75 degrees. So theta, 51.75 degrees. So I can write it here. So 51.75 degrees. So to recap, step 1, I label my sum. Step 2, I write down what's given and what need to be found. Step 3, using what I'm given, I go to my trig ratio, 3 of them, and see where there's a match. Adjacent and hypotenuse, adjacent hypotenuse cosine, therefore I'll use that ratio. Once I have that in place, I now substitute what's given into my trig ratio, and then go to my calculator. Now you have to press your shift button or your sign button or second button, and then your trig ratio. In this case, I press second cos 13 divided by 21, enter, gives me an angle of 51.75 degrees. I'll do a couple more assigned questions just to wrap up this session. So here we do the same process. We have our angle, we have our sides, which is adjacent, and hypotenuse. And I'm going to go back to my trig ratio. Given adjacent equals 4. Hypotenuse equals 5. I'm asked to find the angle theta. Then I go straight to my trig ratios, see where there's a match. Adjacent and hypotenuse cosine, which is over hypotenuse. And I substitute have cos theta 4/5. Then I use my calculator. This can now second cos put my calculator here. second cos 4 divided by 5. Close my bracket, enter, or equal in your case, gives me 36.87 degrees. Notice I'm rounding up to 2 decimal places because it asks me to near 100th of a degree. And always indicate your symbol, degrees, or unit. Let's look at the final one for today. Example assignment 4. Here we have our angle, the opposite side. This will be adjacent side. So given opposite, which is equal to 11, adjacent, which is 9 millimeters, and we have to find theta. So I'll return to my trig reference ratios, opposite and adjacent, opposite and hypotenuse, no, adjacent, hypotenuse, no, but here opposite and adjacent is tangent, so we'll use tangent. Tangent theta is opposite or adjacent. So now substitute the values. We have 11 is opposite over 9. Now I go to my calculator again. So second, because I'm finding the angle, second tangent 11 divided by 9. Then enter. Which gives me 50.71 degrees. So theta is 50.71 degrees. As you can see, the process is fairly similar regardless of what angle you find, as long as you're given the measurement of 2 sides. So to recap, you could find the measure of the angle when we're given the measurement of 2 sides. You have to be given 2 sides to find the angle. We label the size of a triangle. We write down what's given and what's being asked, when you've been asked to find. Then we go to our trig ratios to find where what's given, there's a match, where they match with one of these trig ratios. And they should match. There's only given 2 sides, and you label it correctly. The final, and then you use your calculator, and you always go to your second button in your calculator to calculate it to find your angle.